All right, so sometimes you'll be given a graph, sometimes you'll be given a table. Can you guys see that? Okay. Okay. When you see these two things in the table, think of this as X and think of this as Y. All right, this is helpful. This particular principle is important right here. Give me your eyeballs up here. Thank you. So this is X, that's Y. Now, when we talk about average rate of change, what we're really talking about is something you know very well, and it's slope in between 2 points. All right, so you guys have been given the slope equation like bunches of different ways. This is the most common one I hear, right? In physical science or some kind of science class, you were given this, delta y over delta x, right? That means the change in y divided by change in x. And like I said, this is x and this is y right here. Now, to the question. It says, over which interval, which means from what x to what x, between what two x's, does G have an average rate of change of 0? So between what 2 points on the graph is the change 0? So one kind of quick way to do 0 is just to look at different points that are in common, right? So if I see this has the same y coordinate as this, then that average change is 0, right? It might go down, might go back up, but eventually it's 0. All right, so let's look through this. 0 to 4, is this right? So they're saying from 0 to 4 is the average rate of change 0. No, it's not. If we wanted to figure out what it would be, we would do it this way. We'd say from negative 2 to 6, what happened to all, remember, these are the y coordinates. These are the x coordinates. What happened to the y's? Well, it went up 8, right? And from 0 to 4, it went up 4. So I'd say the average rate of change, or the slope, is 2. That's how I would do that. So if they asked me what it was between 0 and 4, I'd go from 0 to 4. I'd say the y's went up 8, the x's went up 4, and I'd divide them. All right, let's keep going. From negative 2 to 2. From negative 2 to 2. Whoops. G's. There you go. What happened to the y coordinates? Remember, these are the y's, these are the x's. No change. It went up nothing, right? And the x's went up 4. But what's 0 divided by anything? 0. So it says only choose one answer so that we know we're done. Okay, let's do a different one. An average rate of change. Now it's on a graph. So what's the average rate of change of f over the interval negative 1, 4? So what this means is x equals negative 1 and x equals 4. So when they word it like that, that means look at negative 1. So there's the graph. And then go over to 4. There's the graph. Let's measure what happened to the y coordinates. Well, it went up, right? How much did it go up? Yeah, it went up 7. And then how much did it go over? Yeah, and they're both positive, right? Up and right, both positive. So what's the average rate of change? 7/5. Now, you will get some funky fractions on here, so don't think you're wrong if you get some weird fractions that can't be simplified, all right? That's the average rate of change. Now let's do the second assignment, the word problem one. Same idea. It says, when does the number of visitors in the park increase faster? Well, let's look here. From choice A says between outside temperatures of 18 and 20. So they're saying from 18 to 20. Remember, these are x's and these are y's. So the change in y is up 8. The change in x is up 2, right? So that average rate of change or slope is 4. Choice B says, what about between 20 and 27? What about between these two things? Well, what happens? It goes up more, but we still have to divide by 7, right? It's on average. So we went up 28 there, but we went up 7 on the x's, right? What's 28 over 7? It's 4. Oh my gosh, guess what? They increased at the same rate. Okay, when you first look at this table, you think, oh, this is a much bigger jump. It has to be between 20 and 27, right? It kind of messes with your brain a little bit. But they're actually the same rate. Weird. All right, let's do one more of these. Teresa went skydiving. Teresa's height is a function of time, so that means time's going this way. Time is our x, and the height is the y. The question says, what's the approximate average speed? That means slope. What's the slope that she descended between 3 and 8 seconds? I'm going to have to zoom out to mark on this. Sorry. 3 to 8. All right, now this is approximate, so if you get this one, it's kind of funky. Obviously, I'm going to give you the answer anyway. So that's at 650. Pay attention to the scale on these graphs. Okay, what's the height here? About. Yeah, about 375, right? It's halfway between those two squares. So if I went from 650 down to 375, that means I went down how much? Close. $275. There you go. Yep. 275. So I went down 275 and I went over 5 seconds, right? So that was in meters. This was in seconds. If I divide those, what do I get? What's 275 over 5? Somebody help me out. Anybody? It rhymes with 55. Oh, wait, it's 55. All right. Now, if you look down here, 55 is not an answer. That's because it said what to do? Approximate. So then which choice is closest to 55? 54. So you might have more than one where you have to approximate. All right, try out those two, and then we'll talk about the inverses.